So let's have a look at integration of exponential functions. So in this particular question, we are given the function for the speed of a skydiver who jumps from an aeroplane. And then t is the time in seconds. So my y is speed, and my x in this case is time. Now, when it comes to the function of speed and time, we always, when we have that in our exam, we always have to have in the back of our mind that it's connected to distance and time function and acceleration time function. From distance and time, if I derive it, if I create derivative, we get speed and time. And then from speed and time, if we derive it, we get acceleration and time. And then the other way around, from acceleration and time, if I want speed and time, I integrate. And again, from speed and time to get distance and time, we integrate. Okay, so let's see what we need to do. Use integration to find average speed of the skydiver over the first 10 seconds after the jump. Now, I want to point out a few things here. They were very good because they say use integration. But let's say they didn't say that. They not always say that. So they said, find the average speed of the skydiver. That could be the question. Once you are dealing with a question with a function, and in that question with a function, you have this word average. What you are thinking about is integration, because this is average value of a function. That's what I'm looking at. Average value of a function. Now, average value of a function is the average value of what? Of y, isn't it? Because value of the function is the value of y. They are not going to tell you find the average value of a function of speed. In this case, the function has to do with speed, so they're saying average value of speed, because in this question, speed is the function. Okay, so that's how we know when we are using the integration. So how do we do that? So when I'm doing average value of the function, first I have the fraction that has my interval. Then I'm saying I'm giving the function, I'm saying this is a derivative, I'm going to integrate. So in the next part of doing this calculation, we take this and we apply the formulas, isn't it? Be basically saying I am integrating. That's what we do in this part. And then in the last part, we are finding the value. So we are taking our function f, replacing x with the higher interval, minus, again, our function, and replacing x with the lower interval. Okay, so applying that knowledge here, we are integrating. What's our interval? Here, the interval is always described, not here, but always, it's about x values, isn't it? Our x values in this question is about the time, the number of seconds. So here they give us that one, they're saying over the first 10 seconds. So it goes from 0 second to 10. So that's our interval, B higher one at 10 and A lower one being 0. So we are saying our function 54 minus 54 e to the power of minus 0 to t. So we are saying this is derivative and obviously not dx dt because t is here our variable. Now, just to clear something, what I've done, I multiplied that bracket by 54 to make it slightly easier to do. So we have the first part, we are saying this is what we're going to integrate. In the next part, we are integrating, meaning we are applying formulas. Let's not forget about the fraction in the beginning. So how do we integrate each element separate? So 54, one element, and that is our second element. So with 54, what happens? We know integration is a reversal of differentiation. So originally there was, the reason why I have a number here, that means because there was a variable beside it that didn't have a power. Now what happened here? The number crosses over, and then to that we are applying the formula. We go to the table. Where is our table? Integration Let's see, let's look for the formula. So there it is. The formula is saying if you have e taken to the power that is a little bit more than just x, have the number and x, then what happens? You take 1 over that coefficient here at the bottom of the denominator. So multiply 1 over, and our coefficient is what? Minus 0.2, that number that stands beside x. And then e and our power the same, so minus 0.2 t. And we are saying we're going to integrate that within that interval of 10, 0. So we've integrated, we apply the formulas, and then the next stage, finding the value. So 1 over 10, we're not forgetting about our fraction. So first, we take our function and we replacing x with the higher interval, which is 10 in our case. So that will be 54 multiplied by 10 minus 54 multiplied by 1 over minus 0.2 multiplied by e to the power of 0.2, and again multiply by 10. So that's 1 minus, and then again the same function. This time we are replacing t with the lower interval, in our case that is 0. Now you don't have to really work these numbers like in the meaning one by one, because it's easy to make a mistake. You can put everything in the calculator, press equal, and have your answer. Just make sure you write it out well, so that when you are copying it from the paper to the calculator, don't forget, that's the reason why I put those brackets in green, that we need to have those brackets in our calculator. So when we put it, press equal, to the nearest meter per second, we should get 31, and that will be meters per second here.